So we're still talking about lines and angles. Today we're going to talk about not just angles, but triangles. So we're going to watch this video first, and then we're going to practice looking at some angles and some triangles, including our homework from yesterday.
Hi, welcome to Math Antics. In this geometry lesson, we're going to learn all about triangles. You may remember from the lesson about polygons that triangles are special polygons that always have 3 sides and 3 angles. And that's what the word triangle means. Tri means 3, and angles means angles. Okay, that's easy enough. 3 sides, 3 angles. But what else is there to know about triangles? Well, for starters, we're going to learn how to classify triangles. Ooh, such a classy triangle. But seriously, there's 2 different ways to classify or organize triangles. They can be classified by their sides, and they can be classified by their angles.
Okay, so like you said, there's 2 ways that you can classify the triangles. For the most part, we use the angles to classify our triangles in grade. We do sometimes talk about the sides, but for the most part, we're going to focus on the angles in the triangle.
Let's start by classifying triangles by their angles, since we've already learned a lot about angles in the previous videos. You may remember from our first video about angles that there's 3 types of angles. There's right angles, acute angles, and obtuse angles. Well, watch what happens if we use a third line in each of these angles to form closed shapes. Aha! Triangles. And can you guess what these 3 different kinds of triangles are called? Yep. The one made from the right angle is called a right triangle. The one made from the acute angle is called an acute triangle. And the one made from the obtuse angle is called an obtuse triangle. So that's simple enough. But notice that for each of our 3 triangles, the new angles that were formed when we closed the shapes are all acute angles.
So this is really, really important when it comes to triangles, especially if we're going to be paying attention to the angles. Every triangle, no matter what kind of triangle it is, always has at least 2 acute angles. So here they've marked all of the acute angles they made yellow. We can see an obtuse triangle has 2 acute angles and 1 obtuse angle. Right triangle has 2 acute angles and 1 right. And an acute triangle has 2 acute angles, and it actually has a third one. So an acute triangle has all 3 angles that are acute. The other kinds of triangles have only 2 acute angles, right angle, or an obtuse angle.
So triangles always have at least 2 acute angles, and it's the other angle that determines what type it is. That's important to know so you don't get tricked. For any given triangle, just because you see 1 acute angle, that doesn't mean it's an acute triangle.
That is some way that they will try to trick us, is they'll give us a triangle here. They'll show us 1 angle, like let's say this one here, this one that they pointed to, and they'll say, this angle is an acute angle. And then they'll ask you, what kind of triangle is this? And sometimes, just because they tell us one of the angles is acute, people go, oh, well, it has to be an acute triangle then, because they said it's an acute angle. But remember, any kind of triangle will have at least 2 acute angles. So just because you find 1 acute angle, that doesn't mean we know what kind of triangle it is. We have to look at. Now, if you find a right angle, like here, or an obtuse angle, then you know what kind of triangle it is. Because if you find 1 right angle, the other 2 have to be acute. And if you find 1 obtuse angle, the other 2 have to be.
You have to look at all the angles to tell if it's an acute triangle. The situation's easier with right and obtuse triangles because you can only have 1 right or obtuse angle per triangle. So as soon as you spot one of those kinds of angles, you know what type of triangle you have. All right then, classifying triangles by angles is pretty simple, but we can also classify triangles by their sides. If we pay close attention to the length of each side of a triangle, we can see that there's three possibilities. First of all, if all three sides of a triangle are exactly the same length, then we call it an equilateral triangle.
Okay. So they showed us here, they took the triangle, they kind of took it apart, and then they showed us what each of the sides look like stacked right next to each other. If they're all the same length, they call it equilateral because they're saying that the sides are equal. It even has that word equal at the front.
It's kind of a long word, but it's easy to remember because it sounds like it has the word equal in it. To see the second possibility, let's take the top vertice of our equilateral triangle and move it up like this. See what happened? Two of the triangle's sides got stretched by the same amount, but the bottom side remained the same. Now we have a triangle that has only two equal sides, and that's called an isosceles triangle. That's a long word too. The best way to remember that is to look at an isosceles triangle and say its name 20 times as fast as you can. And finally, to see the third
The one thing I will say, a way that I've kind of used to remember it is an isosceles triangle is the one that has the two sides that are the same. If you look at isosceles near the end, it's got two E's. So it's got two E's with the L in the middle. So an isosceles triangle has those two sides that are the same and then one that's different. Usually it's two sides that are longer and one side that's short.
20 times as fast as you can. And finally, to see the third possibility, let's move that same top vertice again, but this time to the left. Now, all the sides are different lengths. This type of triangle is called a scalene triangle.
For the scalene triangles, see that none of the sides are the same length. You can kind of see that like one side's going to be the short side, one side's going to be the medium side, one side is going to be the long. Scalene triangles, if you took it apart like they did here, it kind of reminds me of, I know it's not the way that it always shows up now, but sometimes like on your phone, when you look at how much signal you have, like if you have a good signal or a bad signal, it has these bars that it'll show you. And there's always one big bar and like a middle bar and a little tiny bar and like a dot at the end. What the scalene reminds me of. So it goes from biggest side to smallest side.
So those are the three possibilities when classifying triangles by their sides. Equilateral triangles have three equal sides. Isosceles triangles have only two equal sides. And scalene triangles have no equal sides. That way was pretty easy too. The hardest part is just remembering the names. And now that you know both ways to classify triangles, let's see how you can use them together. Yep, you can use them both at the same time. If you classify triangles both by their angles and by their sides, it turns out that there's several possible combinations. To see what I mean, let's list the three classifications by sides, scalene, isosceles, and equilateral, and the three classifications by angle, right, acute, and obtuse. A scalene triangle can also be a right triangle, like this one. And a scalene triangle can also be either an obtuse or an acute triangle. In the same way, an isosceles triangle can also be acute, like this one, or obtuse, like this one. And in one special case, an isosceles triangle can also be a right triangle, like so. But things are different when it comes to an equilateral triangle. An equilateral triangle is always an acute triangle.
So we can see that for the most part, a triangle could be acute, right, or obtuse, and it could be scalene or isosceles. But for equilateral triangles, those are like really special kinds of triangles. And an equilateral triangle can only be acute triangle. You can't make an equilateral right triangle. You can't make an equilateral. It has to be acute. The only one that's like that.
Because all three sides are exactly the same, all three angles must also be exactly the same. And since we can't have more than one right angle in a triangle, or more than one obtuse angle, all the angles in an equilateral triangle must be acute. Okay, now that you know all about how triangles are classified, let's learn one more really important thing about triangles. In our video about angles and degrees, we learned that we can measure angles and say how big or how small they are using special units called degrees. Well, since triangles are always made up of three angles, each of those angles has its own measurement in degrees. And the important thing is that those three angle measurements, if you combine them, they will always add up to 180 degrees.
So that's true about any triangle, no matter the size, no matter if it's a scalene or isosceles, if it's obtuse or acute. Whenever you measure all three sides or all three angles of the triangle, it'll always add up to 180.
The important thing is that those three angle measurements, if you combine them, they will always add up to 180 degrees. For example, have a look at this triangle. If we were to take a saw and cut it up into three separate angles, and then if we were to take those three angles and rearrange them so that they're right next to each other like this, you can see that the total would be the same as a straight angle. That's 180 degrees. And this will work no matter what type of triangle it is. Knowing that a triangle's angles will always add up to 180 degrees can really help you out when solving geometry problems. There's a whole lot of situations where you'll know what two of the angles are, but you need to figure out what the third angle is, like in this problem. With this triangle, we're told that one of the angles is 35 degrees and the other is 45 degrees, but the third angle is unknown. We need to figure out what it is. Since we know that the total must be 180 degrees, we can just add up the angles that we do know, and then we subtract that from 180 degrees to see what's left over.
So this would be a good part for subtraction. We're looking for that missing piece. We know two of the pieces. We want to know the third one. So we take our total. We know it's always going to be 180. Subtract the pieces, and we'll find what's left over. Yes, Alexa.
Oh, I need to go.
That's okay. Go ahead.
Okay, thank you. Bye.
Bye.
The leftover amount must be the measurement of the unknown angle. So, 35 plus 45 equals 80 degrees. And when we take that 80 and subtract it from 180, we get 100 degrees left over. That means that our unknown angle is 100 degrees. And you can always check your answer by adding up all the angles to make sure you get 180.
That actually works even if we're not talking about triangles. If you do subtraction and you're not sure that you got the correct answer, you could always work backwards. You could add these two numbers and see if you get your original answer again. If you get the same answer, you know you did your subtraction correctly. You know everything is perfect. You know you didn't make a mistake. If you add these two numbers up and you kind of notice, oh, I got a different answer, then you made a mistake when you did your subtraction. So that you can go back and take another look at it.
That means that our unknown angle is 100 degrees. And you can always check your answer by adding up all the angles to make sure you get 180. So you can see why it's so important to know that a triangle's angles add up to 180 degrees. Well, that's all we're going to learn about triangles in this video. Remember, the key to really learning math is to do it. So be sure to practice by doing the exercises for this section.
Okay. So speaking of angles, what I want you to do now is go ahead and grab your homework from last night. We're going to look over it and see if we found the right kinds of angles. So go ahead, grab your homework. Make sure that we turn our cameras back on. Make sure we leave our microphones off and check our homework. So let's take a look at our homework. And let's see if we got them right or if we made some mistakes. So for angle number 1, I'm going to take the corner or the vertex of my sticky note. I'm going to put it inside the corner or the vertex of my angle. I'm going to try to see if I can line it up. Try to get it to fit. About as close as I can get it. I can see one of the lines of the angles, but the other line from the angle gets covered up. We talked about these yesterday. If I can see one of my lines, but the other line gets covered up, who remembers what kind of angle was that? If I can see one line, but the other line is covered up. If it's too small for my sticky note to fit, what kind of angle is it? Violet, what kind of angle is it if the sticky note's too small to fit?
Acute.
It's an acute angle. Remember, if it's too small, it's small like a little baby, a cute little baby. So this would be an acute angle. And like they said in our video today, if I took a line and I connected those two lines, I'd have an acute triangle. All right. For angle number 2, same thing. I'm going to take the vertex of my sticky note. I'm going to stick it inside my angle. I'm going to try to line up my two vertexes. Oh, that one fits perfectly. So I can see both of my lines. Nothing's covered up. Nothing's sticking out. What kind of angle is it when our sticky note fits perfectly? Not too big. It's not too small. Aideen?
A right angle.
It's a right angle. Because like we said, like Goldilocks, it fits just right. And again, just like our video, if I take a line and I connect the two other lines of my angle, I end up with a right triangle. Angle number 3. Same thing. I'm going to take the vertex of my sticky note. I'm going to put it inside the vertex of my angle. Try to see if I can line it up. Okay. That's close. But I can see both of my lines. Nothing's covered up. But I noticed that one of the lines is sticking way out to the side here. What kind of angle is it if one of my lines is sticking out way far to the side? What kind of angle was it when one of the sides is sticking out? It would be an obtuse angle. So angle 3 was an obtuse angle. And again, if I take a line, connect my other lines, I end up with an obtuse triangle. Brianna, make sure that you raise your hand when you have the answer to a question. Don't just type it out. That way everyone gets a fair chance to answer. Angle number 4. I'm going to try again. Vertex of my sticky note goes into the vertex of my angle. It's kind of close, but the angle's a little bit too small. What kind of angle do I have for number 4? Jada, what kind of angle do I have for number 4?
If I was, it's an acute angle.
It's an acute angle. I'm going to draw my line, and now I have an acute triangle. And angle 5. Vertex of my sticky note goes with the vertex of my angle. I'll try to line it up. I got a line that sticks out. What kind of angle do I have for number 5? Brianna?
Obtuse.
It's an obtuse angle. And again, if I take my pencil and I draw a line to connect the two other lines, I have an obtuse triangle. Okay, let's practice with some more together. Okay. I'm gonna look at problem number 8 or angle number 8.
Mister, I can't see the last one.
Oh, sorry.
Okay, thank you.
I'm gonna take my sticky note and I'm gonna look at angle number 8. I'm gonna take the vertex of the sticky note, put it into the vertex of my angle. Who can tell me what kind of angle do I have for number 8? What kind of angle would this be? Jaylene, what kind of angle do I have here?
A right angle?
So does this angle, does my sticky note fit in this angle just right? Can I see both of my lines? It fits perfectly? No, it doesn't fit perfectly. So it can't be a right. Remember, the right angles, sticky note fits perfectly. But this angle I notice is a little bit too small. So what kind of angle would this be? Because I can see this line, this WX line, but the other one, the one that was here, is underneath the sticky note. So what kind of angle is it where the sticky note is too big, that the angle's too small for the sticky note to fit? Irene?
It's an acute angle.
It's an acute angle, like a cute little baby. It's too small. All right, let's try another practice. Let's try number 7. Okay, number 7. I'm going to take my sticky note and use the vertex, corner of my sticky note, and put it in the vortex, not the vortex, the vertex, the corner of my angle. Right? It kind of fits. Sort of. It's not really perfect though. Who can tell me what kind of angle I'd have here? What kind of angle do I have if it doesn't fit perfectly? There's like extra room if I have a part that's sticking out. What kind of angle would I have here? Heidi?
It's an obtuse angle.
This is an obtuse angle because the angle is too big for my sticky note. Okay, let's try a few more. 13. Same thing. Vertex of the sticky note. Vertex of the angle. Ooh. Alright, that one fits really nicely. I still see both of my lines and everything. Who can tell me what kind of angle do I have if my sticky note fits like this? If it fits really nice. Ezekiel, what do you think? What kind of angle do I have here? My sticky note fits nice like this.
A right angle.
A right angle, perfect, because it fits just right. The Goldilocks and the Three Bears. Just right. Okay. Let's try like 2 or 3 more. Number 10.
Mister,
Yes, ma'am.
when we do 10, when we do like a few more, are we gonna do the rest by ourselves?
Not the rest on this page, no. We do have some more practice tonight, but not on this page.
Okay.
Okay, so let's do number 10. Vertex of my sticky note. goes into the vertex of my angle. Who can tell me? Angle 10. What kind of angle do I have? What kind of angle would this be? Bella? What kind of angle would I have here? Okay, Brianna. Would this be an acute angle? Would this be a right angle? Or would this be an obtuse angle? Since I can see the sticky note inside the angle, Bella, can you tell me, is this angle too small for the sticky note? Too big for the sticky note? Or does it fit it perfectly? Make sure that you unmute yourself when you're going to answer.
Small.
Oh, it's too small. So the sticky note doesn't fit? It's got some extra room
Nothing's
to it. Oh. Let's see. Who can help her out, though? Angle 10. Bailey? What kind of angle do I have here? For angle 10.
Obtuse.
An obtuse. The angle is too big for my sticky note. I've got all this extra room. Obtuse angle. Okay? Number 12. Okay, number 12. Vertex of my sticky note. Vertex of my angle. Okay. What kind of angle do I have here? Okay?
What?
What kind of angle do I have here, Nakai?
Um, a right angle. Oh,
So-
acute.
This is an acute angle. The angle is too small for my sticky note because I can't see the other side. So this is an acute angle. All right, one more and then we can move on. Number 6. Okay. Vertex of my sticky note. Vertex of my angle. What kind of angle do I have? Irene?
A right angle.
A right angle, because this fits perfectly. Okay, you guys are good at this. So that's really awesome. Okay. Tonight, what you're going to do is just like they did in that video. The page you're going to do tonight is triangles 3B. Okay, it's just got 6 problems on it. 6 triangles. Just like we were just doing, you're going to use a sticky note or a piece of paper, and you're going to figure out what angles this triangle has. Then it's asking us, what kind of triangle do we have? Is it an acute triangle? Is it a right triangle? Or is it an obtuse triangle? What kind of triangle do we have? Now remember, the right triangles have one right angle. The obtuse triangles have one obtuse angle. But acute triangles have to have 3 acute angles. And that's going to be our homework for tonight. Okay? Triangles 3B. Just these 6 triangles. You don't have to do the backside or do anything extra. Just the page that says triangles 3B.